Hello, this is Amita here. Hello, Warren.
Hi.
Hi. So we wanted to ask you, there's a small group here who are interested in PIC simulations. And we wanted to know about Osiris 4.0. You mentioned that it has QED effects and radiation reaction effects, right?
Yes.
So, what kind of MOU should we sign so that we get access to Osiris 4.0? That is, some people are interested in knowing that.
Well, so I think the way to do it is if everyone is at the same lab working under the same person, then there's an MOU, and then you list those who will be also getting access to the code. And then I also, with respect to the QED and the radiation reaction, I don't believe there's an issue, but I need to discuss with my colleague, Luis Silva at IST in Portugal, who their group is leading the effort in adding that aspect into the code. But I don't think there's an issue with getting access to it.
I see. Okay. So Osiris 4.0 has these two effects, right? QED and radiation reaction?
Yes.
Okay. So we can use it for any problem that we wish to do.
Well, I mean, obviously it has to be appropriate, but I think because there's a learning curve to using these tools that I think there should be an ongoing interaction could be formal or informal collaboration. Depending on the mutual.
I meant collaboration only, but we can plan for some proposals or something like that together.
I mean, within India, you're saying you're writing proposals to the Indian government to work on these problems.
We can
Is that what you mean?
We can write proposals for support, but we can collaborate with each other.
Yes.
Yes. And you.
I mean, one could view it, there's users and there are developers of these tools.
Yes.
And obviously, over time, you would like people to feel that they can understand and would help to develop it.
Precisely. Somebody told me about a consortium that you are planning to have around this code or something like that, in which
that already exists. So that consortium is really between UCLA and IST in Portugal. And so if someone in Europe wants to get access to it, they go through IST. If you are in Asia or North America or whatever, then you go through UCLA. That's the way we have done it. But it's the same. The code is being developed by IST and UCLA, and we'd like to get it more widely available. And the way we have done it is not through an open source project, but through this MOU. While QuickPick will be open source.
Yes, you mentioned that. But so I mean, like through consortium, we have to go through UCLA, right? We can be a part of consortium. Can we be a part of?
You're not part of the consortium. You are. The consortium could grow over time. But really, the consortium is UCLA and IST, and the consortium makes available Osiris to others through the MOU.
Okay.
I mean, I don't know whether that language matters, but that's the way it is set up.
So
I know
once
people from, I don't know whether it's your institute, have worked and been involved at IST or no?
we have
Is there anybody?
we have one student working at IST. One of our student is working at IST.
Say that again?
One of our student, Professor Kau's student, is now at IST as a postdoc, is working as a postdoc.
Yeah, okay. There you
So he has worked with Osiris 4.0 and all.
Right. So this is a way then he's learning, he'll bring his knowledge. I assume he'll come back to India at some point.
Yes,
and
yes.
I know somebody spent a postdoc with Chan Joshi at UCLA.
Yes.
And he did sign an MOU, but that was, the code is now 4.0. I forget which version of the code he was using.
2.5. 2.5 or 2.0, something like that. Yes.
I think it was probably 3.0, but anyway, yes. So 4.0, but 4.0 has, plus it has this quasi, well, we're putting it in now at UCLA, this quasi 3D algorithm that I was describing. And there's the boosted frame effort is being done at UCLA. So there's that hopefully capability that will be in the code.
I didn't get it. What was it?
The boosted frame capability.
Okay, the boosted frame capability. Okay. So that has come later. It's not in the Osiris 2.5 version?
No.
Oh. And the GPU and other aspects are also in the later version. 4.0 has it.
The GPU, the Intel Phi capability is in 4.0. It's it always is being polished up. The GPU was done by my graduate student, and I think he's trying to get it into the main branch. It may not be in there yet, but if you get access to 4.0, you'll see the work being done in which that part of it and then is added in. Right. So once you get access to 4.0, then you see what, then you get access to the repository in the GitHub account, and you see work being done by the main developers. And then when something is ready, it'll be put into the main branch.
I see. Okay. So we write to you about it, or what do we do?
Yeah. So yes, I think that. Let me just check with Lewis. But so if you contact me, I send it to you. You tell me a list of people who you want to get access to it.
Okay.
And it may be that it will make sense for people to visit.
Yes.
We could have a little kind of a workshop on how to use it.
Yes.
We could do that.
Yeah. Okay. Yesterday you were saying that about this that you can, the travel and stay support. Also, you will subsidize or something like that for these possible support?
It depends. I have money to hold workshops. So if I'm able to do it in the context of a large number of people coming to learn and discuss the code, then I could help to offset some. So there's some money, so it depends on the number of people. And then if we're getting serious about trying to arrange something and how many people, we need to talk about it, and I can see what I could potentially do. Okay. But I couldn't do the whole thing, but I could certainly talk about offsetting something.
So when are you planning to have this workshop?
Well, it depends on, I mean, what could drive it is if we're in a discussion and there are enough people from your institute, then I could then use that to then pick a date and then advertise it more widely, knowing that there's enough people that are coming, and then I could advertise it more widely.
Okay.
So the date hasn't been set, but we could work to find a date, and then I could advertise.
Okay. Thank you. So anybody has any questions?
Is there interest in Quick Pick or no? I mean, I know it's not.
Quick Pick people do not have any interest. They will be interested in Osiris 4.0 and something.
Okay.
Any other questions?
Are there? Oh, go ahead.
Hello. Hi, Warren. This is Bhavesh here.
Hi.
Hi. So, I mean, could we contribute as a developer after a certain stage?
Say that again?
I mean, if we want to contribute as a developer to the code, so can we do that?
Yes. I mean, the way it would operate is, and the reason why people within the consortium do not want to make Osiris completely open source is that through the MOU that we are more aware of who is serious about using it and potentially working on it. And so if anybody has an idea or thinks about something they want to add to it, then at that point they can bring that to the attention of the main developers, who can then work with them so that it's done properly. But clearly, the more people who want to improve it or work on some aspect to it, that's going to be better, and the code will evolve more rapidly.
Yeah, that's true.
So it's more, someone like yourself, if you wanted to, you'd say, I had an idea, I wanted to do this. You put it out on the GitHub, then Ricardo Fonseca or Frank Zung or Adam's people at UCLA or IST would then say, okay, let's discuss it, and then provide guidance as to how you could, whether there's enough interest for this to be something that would be then added back to the main branch if it was successful. If that's the case, then providing guidance and advice on how to do what you're interested in doing. Right. The other aspect is you run it, you'll find bugs potentially or issues, and you provide feedback, which will help the code get better more quickly.
Hello, sir. I have another question. You have made a visualization tool, Vis XD, for the visualization of Osiris data. So can we have the access to the Vis XD too with the Osiris, or?
I believe so. There are other. There's Vis XD, but the data is written out in HDF5, and people are also writing Python routines. So it isn't. Vis XD, I believe, is available through the MOU. I have to confirm.
It comes with the Osiris.
What's that?
It comes with the same MOU which will be signed for the Osiris.
Generally, yes. I just have to confirm with IST how they want to handle that as the number of people grow. But I also want to stress that that's another place where everyone can help to contribute to development, because there are other people working on not, making it more general, let's say Python or other visualization routines. So you're not, Vis XD right now is based on to IDL. So if there are other people in our group who use MATLAB, there are other people who are writing Python.
Yes.
So the whole idea is that the more people are using it and they have other ideas on how to improve the visualization, that effort can grow as well. But Vis XD is always there to use in addition.
We do have the access to MATLAB, and we have some visualization in MATLAB script. But then we would like to have the Vis XD in ideal too. Like we want to develop it, and probably many of us would like to develop Osiris and other visualization softwares too.
Okay. So I believe that's not a problem. So I just need to confirm that with Lewis and Ricardo on the Vis XD. But the other is, if you have other tools that, as a group, having a discussion about what is a plan on the visualization, because Ricardo and others recognize that having it based on IDL is not necessarily what we want in the long run.
Yeah.
So Vis XD itself may evolve. And if that's the case, perhaps it's saying, well, let's talk about how we can share and ideas on how to make that evolve.
Sure.
Yes.
Yeah.
Anyone else? You want to ask? I was wondering whether you are planning in the long run to have a QCD based PIC, chromodynamics.
Not in the short term. I think these sorts of things need to be tested out, let's say with the QED and the radiation reaction, and let's see how successful it is. And one of the main challenges with that is this particle merging and routine that had to be added in there. So there are a lot of subtleties and challenges to using these modules. There's going to be a big learning curve. Mm-hmm. Once people start to see it and they see how it's added in the code, people may have ideas on thinking about how to extend it, but now, I know there wasn't not the interest in quick pick, because the main interest, it sounds like, is people want to do very, very high intensity laser matter.
Yes.
And there is an interest in the more moderate intensity or beam plasma interactions. Is that my understanding?
Yes, beam plasma interaction and fast ignition problems. Overdense
there's
cases.
fast ignition.
Overdense cases,
Okay.
we would like to apply those ideas
Okay.
for that.
So we have other codes, not to confuse things, but if you go to the site, we have what are a whole library for FFT-based PIC codes.
Okay.
Some of it we will hope to add into Osiris. It's called UPIC.
Mm-hmm.
So if you go to the site, the Pixie site, all these codes are open source. Some of them are short little demos that demonstrate parallelization methods, how to port codes to GPUs, PIC codes. Mm-hmm. And so they're also useful for learning some fundamental concepts, as well as building your own codes that you could use. Let's say we're developing one for overdense laser plasma interactions, sort of a more production level code based on FFTs. So I would, some of it is useful just to see all this collection of libraries for PIC codes that are based on FFTs. It will evolve to some to production codes. Some exist already. We also have an open source code that's a Vlasov-Fokker-Planck code.
Okay.
So that is for heat transport. So if it sounds like there's fast ignition or other aspects with respect to high energy density plasmas, but this is not laser plasma interactions.
Yes.
So there's other codes and libraries that are completely open source on the website, and it will grow. If there is interest within the group of learning more about it, would be happy to talk about that as well.
Yeah, we would like to have the overdense case especially. We would like to know about it. And
The the other part of this is that we're trying to develop what we call educational software. All right, so what I mean by that is, and you have a large group of very smart, well-trained plasma physicists there. So if there was a concept that you learn in your course, or not some large simulation that would take 1 million cores, but a much smaller number, that you thought would be useful as a kind of a lab course for teaching students, or even teaching postdocs a concept. We'd like to work together to develop concepts for this.
That surely I'd be very much interested in.
So like, let's say the Weibull instability, beam plasma, Landau damping. Say, I want to teach that. I want to have a demo of that that's based on the kinetic software. So you have an idea for that, please let us know, and we'd be very interested in pursuing that as well.
Okay, that's wonderful.
Hi Warren, I'm Ajit. You were mentioning, I'm Ajit. Ajit.
Yeah. I can't see it. There. Hi.
Yeah, I wish to ask, you were mentioning that QuickPick you are making it open source.
Yes. It is open source, yes.
It is already open source?
Yes.
It's available on the same site where this other libraries are there?
Yeah, so you go to it's www.picsc, Pixie, okay, .idri, .ucla.edu. So if you write that, you can even go to the website now to make sure it works. So PICKSC .idre .ucla.edu.
This has got beam plasma interaction modules, I hope so.
Say that again?
This has got beam plasma interaction modules too. I mean,
well, right now, yeah. QuickPick, the open source version of QuickPick, only has beam plasma interaction capability.
No laser plasma interaction?
No. So what happens is that part of the code, which existed several years ago, has not been kept up and is not fully working. If somebody there, so what you would do for that is you would add the Ponner motive guiding center capability to model a laser. So you'd model a laser as an envelope equation for the normalized vector potential, and then
I was developing a version where based on the VLPL framework, POCO, where I had implemented this beam plasma, but when I started implementing this guiding center approximation, what would happen that after traveling say 100 or 150 micron, the laser pulse would blow up. So I think I need to discuss it separately with you.
Right, so there's another code, to give you a sense, there's a code called WAKE, W-A-K-E, that developed by Mora and Atkinson. Okay, now that code is only two-dimensional. It's an RZ code. And it has this, they were the ones who developed the Ponner motive guiding center approach. So that is a useful code to get to at least run the problems you were saying, because if it doesn't blow up there, then you know the idea is going to work. A QuickPick is fully three-dimensional. So what it is a fully three-dimensional quasi-static code. So Tom Atkinson's student, James Cooley, this is many years ago, we worked together to add the Ponner motive guiding center into QuickPick. Okay, now, just to put things in perspective, if you run Osiris with what we call the Quasi 3D.
Yeah.
Okay, that is, and we start to believe that has advantages for many problems with near azimuthal symmetry. And because of that, we have stopped working on the Ponomotive Guiding Center in QuickPick. But if somebody wanted to work with us and had experience with it, a lot of that framework for adding it in exists. So if you came out and visited and we showed you where we were at and you wanted to work within it, we could definitely talk about it. The other thing is, clearly the radiation reaction can easily be implemented into QuickPick. So if one looks at the radiation reaction, we have a version of it in QuickPick, but if one wanted to improve it and add some of the capabilities of Osiris into it. So there's a lot of room for continuing to work together.
What do you mean when you say that Osiris 4.0 has Quasi 3D? So this Quasi 3D is different from envelope approximation?
Yes. The Quasi 3D is where, so I only had a few minutes to say it the other day, was that, RZ codes where you have complete azimuthal symmetry have been very useful for beam plasma interactions. But a laser pulse is not azimuthally symmetric if you have a linearly polarized laser. So you can't model laser plasma interactions with an RZ code. So instead what you do is you expand the fields in azimuthal harmonics. So you write it in RZ and then you expand in a sum over e to the im phi. Okay? You then realize a linearly polarized laser is only the m equal 1 mode. So I only need to include the m equal 1. So this idea was done by Lifshitz at LOA. And we implemented in Osiris with a new charge-conserving current deposit method that's for it. And then you can include an arbitrary number of harmonics, but typically it only include 1. And this allows you to do kind of problems in which there's near azimuthal symmetry with a savings of about a factor of 100. Because you don't need, it's like a 2D code modeling a problem. Okay? So that is in Osiris. Right now we are adding it. It was in 3.0. My grad student did this. And now he is adding it into 4.0. So it should be in 4.0 in a matter of weeks. But we've used it a lot in 3.0 for a lot of physics studies.
Thank you. And
sure.
I will write you about this QuickPick. I would love to add that, improve that laser module in RG.
Okay, sure. Okay.
Okay, thank you.
Sure.
Okay. So thank you, Warren, for your time.
Sure. Thank you.
Okay.
All right. Get some sleep.
So we'll
Bye.
talk to you sometime later because we can contact you on Skype later if we have any questions.
Sure. Sure.
Okay, and we'll write to
Sure.
you. Okay.
Okay.
Bye.
All right. Bye.
Bye.